So very good morning to all of you students. So before discussing parallel computing or what exactly the parallel computing is, first let's see what is serial computing. Okay. So traditionally, when we suppose written for a particular serial computing, we consider it to solve, or traditionally we are writing a particular software that is to be done the computation in a serial way. To solve a problem, which is nothing but discrete series of instructions are first written. Those instructions are executed sequentially, one after another on a processor. They are executed on a single processor. So only one instruction can be executed on that particular processor. So for example, we are having problem statement of this problem. The set of instructions are written. These instructions are executed one by one on a single processor. So these instructions are sequentially processed only by one. So this is called as a serial computing. So now let's see whatever the things we have done, then let's see the parallel computing. So in this, parallel computing is nothing but considering the multiple computer resources to solve a computational problem and simultaneously executed a different task. So in this problem, it's broken into discrete part that can be executed concurrently for each part. So the problem is broken into discrete parts, and each part is further broken down in a series of instructions. And the instructions are written, those are a set of instructions, which is nothing but simultaneously executed after completion of one individual result, and that can be combined. Say for example, so this is a given problem. In that, we are considering the divided into number of tasks, which is nothing but subtasks, and that we are having 4 subtasks of here. For each subtask, different set of instructions can be written for those particular instruction and can be executed on different processor one by one, and they are executed simultaneously. It is called as a parallel computing. The computation problem should be such that it can be broken into discrete piece of work and that can be solved simultaneously. It executes multiple instructions simultaneously and can be solved in a less time by using a multiple computer resources, and that a single computer resources. So the computer resources, which is nothing but we are having two types over here. Computer parallel computing. So we are considering the computational problem should be able to break into discrete piece of work that can be solved simultaneously and execute multiple instruction at any moment. And then we can solve it in a less time with a multiple computer resources than with a single compute resource. So the compute resources are typically of two types. You have to consider here a single computer with multiple processor. We are having consideration of that as an arbitrary number of such computers connected by the network. So now let's understand the types of parallelism. Here there are three types of parallelism. Rather, we can say there are three levels of parallelism. Let's see those levels of parallelism or types of parallelism one by one. Which is first of all, we are considering three types. So what is that? The first one is bit level parallelism. So this type of parallelism is based on increasing processor, which we are considering the bit size. By increasing the number of bits in the processor, reduce the number of instructions required for computation. And in one instruction, two operations can be get performed. If you consider it with the processor, 16 or 8-bit processor, 16-bit processor, or 32-bit processors, so we can perform one or more operations on 1-bit instructions based on that. So basically, we are considering the number of bits in that particular processor. Say, for example, we have to consider the addition of two 16-bit integers. So in this case, if you want to perform operation on 8-bit processor, then we require two instructions are required. And if you perform this particular same operation on 16-bit processor, then we require one instruction to execute. So 8-bit processor, two instruction required, 16-bit processor, one instruction is required. So this type of parallelism is possible on standalone computer. So by increasing the number of bits in the processor, we can increase the parallelism. That is called as a bit level parallelism. So this type of parallelism we can implement on a standalone computer. So next, consider here next type of the parallelism, which is nothing but instruction level parallelism. So we'll consider this slide. So in this type of parallelism, independent instructions can be executed in parallel, which is nothing but instruction level parallelism. So these instructions which are independent, they are not dependent from data or perspective or from any other perspective. So they can be executed in a parallel. So this type of parallelism is possible on standalone computer as well as parallel computers. So for example, consider the 7 instructions. Oh, here I written that. So these are the 7 instructions to execute this part where the 7 cycles are required. So the first, there are 3 instructions are to be related to arithmetic operations. So we are considering A is assigned to 10 value, B is equal to 5, and finally we are performing the addition, C is equal to A plus B. And we are performing this operation. Then next 3 instructions are related to the things where we are considering the operation for file read file, right? File open, X is equal to read, and then closing the file. So instructions number 7, which is related to adding the result. From the above operation, if you compare these instructions, so is to be get added